Thank you everyone for attending. And I would like to start first by thanking Engineer Khalid, who spoke a little bit earlier about the demand control ventilation, because in our sustainability case study, we're going to exactly showcase how demand control ventilation in car parks works. So, of course, first we're going to talk about sustainability goals, Saudi Vision 2030 for net zero targets by 2060. The ventilation, of course, with Mustadam standard is the standard for building systems prioritizing air quality, thermal comfort, and ventilation, and the energy code, Saudi Building Code 601 for updated for ventilation, insulation, efficiency. And then, of course, demand control ventilation for control of CO2 emission inside a building. So our target, of course, to set the right ventilation standards, adopting the best available technology, because this is what's vital for the Kingdom of Saudi. The critical role of car park ventilation. Car park ventilation, of course, is very important, especially in projects happening at the moment all over Saudi. I know the traffic is not that good in the kingdom. The demand on car park ventilation is very high. The demand of car parks underground basement is very high, and therefore, of course, we need to have solutions for a proper car park ventilation. The most important essential part is the essential ventilation to ensure safety, toxic gas controls, CO emissions, and O emissions, fire mode in case of fire. We need to control fire, and our standards, what we follow in Systemair, is the active management system, active fire management system, and life safety. Reduce risks by controlling the smoke in one particular area. Of course, we all know that fire doesn't kill people, it's smoke that kills people. So this is a typical ducted system. This is what's, I don't want to say common, but it's used in the kingdom and used across GCC. The shift toward jet fan system, but you can see is a bit chaotic, it's a bit all over the place. It makes the car park a little bit more closed area, and this is how compared to a jet fan system look like. Why quality car park ventilation matters? First is energy efficiency. We're able to reduce energy consumption by more than 30%. Airflow performance by decreasing the leakage inside ducting, by decreasing the bacteria, molds, VOCs, and allergies inside a duct. Material sustainability, recycling of ducting, and maintenance impact, frequent uses of chemicals in order to clean ducts, etc. All that is completely gone with the jet fan system. Now, the easy also for the jet fans, the flexibility to install. It's very easy products to install. Space-saving design, as I showed you earlier in the picture. Energy efficiency, we'll show it a bit later on. Smart control. So what we are able to provide you as Systemair is a full solution, smart control system. We're not just installing the muscles, we're not just installing the fans. We are offering a full solution from design to installation to controls, which is the most important part. And of course, our products are certified. And then, of course, we talk about simplified maintenance for the product, about lower generator demand, reversible operation for zoning. We will see a bit example later on, quiet environment, and sustainable construction for the products. What we offer at Systemair is we offer, of course, the fans. We offer the exhaust supply, fire-rated certified products. We offer the CO/NO system. We offer the MCC panels. And I can proudly say that now Systemair Saudi Arabia is executing projects with a full product range made in Saudi Arabia. And that's what's very important for us in order to push ourselves and then, of course, push with the Vision 2030 of localization of production in the Saudi market. So our products are certified, made in Saudi Arabia, reliable. We're offering a full solution for our clients. And the most important part for the demand control ventilation is, of course, the MCC panel. Our sustainable approach is to offer a smart fan technology, variable frequency drive to control the fans, demand control ventilation, zoning and sequencing, which we will talk a bit later about it, and system optimization. Sorry. Efficiency, performance, and reliability of the system is very important for us. Energy efficiency, we can reduce up to 80% energy efficiency. EC motor technology, of course, is needed. Compact, duct-free design. Airflow optimization and durable and low noise level. You will see a bit later on in how we design the system to run at lowest energy consumption possible and the lowest energy and lowest noise level possible. I will leave this a bit to my colleague to talk about the brain of the engineering that we do for the demand ventilation.
So for the car park ventilation systems, so basically it might look like some colorful picture, but it's actually having around thousands of rows, let's say. So it's called demand control ventilation, where we focus on optimizing the ventilation based on the need, based on the occupancy, or the pollutant levels. So on traditional system where the fans might be running continuously throughout the day, throughout the working hours, in this case what we do is we optimize and it just run based on the demand so that it cuts the ventilation by around 40 to 60%.
So as my colleague mentioned, this is the brain. This is the engineering that we add as a value to the systems that we are offering to our clients. Now, we will give you a live example of a car park we supplied around 2 years ago. The Raiya car park is called Bujeri. This is a typical example of the car park where we are splitting the car park into three different zones, Zone A, Zone B, and Zone C, with the intake and extract at different locations. The target of active smoke management is to keep the smoke in one zone. In case of fire in Zone A, we will control the smoke to remain in Zone A, and Zone B and Zone C will remain clear. For people's safety, for firefighters, for easier access. Then, of course, the next step is the distribution of jet fans. We spoke a bit earlier about reversibility. On the area where we have common zones, we have reversibility of products, of jet fans. We're able to reverse the airflow and keep the flow in a certain area. Now, this is a CFD simulation that we also provide, and as you can see, in case of fire in one zone, even after 2,000 seconds, the smoke is remaining in Zone A. This way, we maintain Zone B and Zone C completely free. Now, the advantage against passive smoke management let the building burn, and then the firefighters, or then they go and try to extract the smoke. The active smoke management, we make sure that we are controlling the smoke in one particular zone. And this is very important in projects here in Saudi. Value engineering, what we have added, as you can see, we have reduced the number of jet fans from original design from 420 jet fans to 169 jet fans. The CO sensors from 420 to 220, cutting cables, costing, axial fans, main fans from 60 to 40, fire rating optimization dropping from 400 degrees to 300 degrees, and control panels, simplified control panels. The original design was 1 control panel per fan. We have optimized it from 47 control panels to 4 main control panels. Major saving on equipment cabling. We'll just show you a quick example of what we saved. The original design was showing 1,000 consumption on the axial fans of 1,110 kilowatts. With our design is 740 kilowatts. And the jet fans from 715 kilowatt to 287 kilowatt. So just material impact. And then, of course, CO sensors from 420 to 220. Just material impact, direct material impact. In this project, a saving of more than 3.2 million SAR. Just material ventilation. We're not talking about cables. We're not talking about panels, etc. And then, of course, for cabling, we saved over 12,000 meters of cables due to this. Now, the cost impact, in addition with the brain. So we spoke about design of the products. Now we talk about the brain. The sequence of operation that my colleague showed you shows you here how much we are saving. The fan energy consumption in traditional ventilation based on 11 hours running per day is 300 megawatt per year, versus in our design on 0 to 25 ppm, just 10 megawatts per year. You are saving more than 288 megawatt. And on a second mode, so we are splitting the levels, zone 1, zone 2, level 1, level 2, level 3, level 4. On level 2, we go from 298 to 30 kilowatt per demand controlled ventilation. So we have a total annual in the car park savings in level 1, 650,000 kilogram or 650 ton, and on level 2 around 600 ton, which is energy consumption also for the client. We are saving in level 1 230,000 SAR per year and 214,000 SAR for level 2 operation. That's the savings direct impact on our product. As I mentioned, there's a lot of additional savings, maintenance costs, also savings that we are having for our system. So some references for Systemair. We have been recently, as I said, Systemair has been in the Saudi market for 15 years. For the last 5 years now, we are a foreign direct investment with our region headquarter in Saudi and also a new factory now. Hopefully the opening will be next month. We're talking about around 13,000 square meter production facility where we will be producing a lot of products here. Some references for our projects: Asr al-Hakam downtown, Western Metro stations, Wujari car park, Samhan, Riyadh Park Mall, Souk 7 in Jeddah, Basatin office, Palm Views. These 2 projects where we supplied the full system from A to Z. King Salman Knowledge District, 7 Jazan, and the list goes on and goes on for us. In conclusion, sustainable ventilation is very important. That's what we are aiming for. Smart technology, we're trying to use smart technology as much as possible, and then future-ready approach. This is the future of ventilation in the opinion of Systemair. And this is what we are aiming to support the Kingdom of Saudi to achieve more and more for the future. So, thank you very much.